This is presentation 7.8. The topic is inferences regarding proportions and sample sizes. We want to acknowledge the development team of Brad Spencer and Amanda. To illustrate the theory, we're going to consider the case of a poll, a random sample, 588 people in central Alberta, and 321 people indicated that he or she would vote Conservative if an election were held today. Find a 95% confidence interval estimate of the proportion for the population. A point estimate of that parameter is p hat 321 over 588, or 54.6%, and this is the sampling distribution coming on the screen here. The standard error is given by this formulation where we use the p hat from above, the standard error 0.0205, and that's coming on the screen here now. That's the 60% region about the population proportion. The margin of error is given by plus or minus 1.96 times your standard error, which gives rise to the margin of error of 0.04, and that's coming on the screen here. This is the region about the proportion in which 95% of the sample proportions will fall. And the confidence interval, of course, is your estimate p hat plus or minus your margin of error. And that's coming on the screen here now. The p hat 54.6 plus or minus your margin of error, giving rise to a confidence interval between 50.6% and 58.6%. When we give you 95% confidence, this interval will capture the population proportion. Now we're going to take off from this. We want to find out how large the sample size n must be in order to find an estimate of the proportion p to within an error of plus or minus 0.02 with 99% confidence. Now look on the screen, coming on the screen here now. For 99% confidence, we need a z-score of plus or minus 2.575, and the error is plus or minus 0.02, and that means, coming on the screen here now, we have to solve this for n. We solve for n, we square both sides, manipulate it in this fashion, and we find that sample size is 4110, and that's the sample size necessary to find an estimate of the population proportion to within 0.02 with 99% reliability. In the general case of solving for n, we have this expression given here, which comes from up here at the top. Now, when no estimate of p is known, if we don't have a value of p hat, we have this general expression here. Now watch what happens. We substitute these values in, and the error term is plus or minus 0.02, 99% confidence 2.575. This is a quadratic in p. The intercepts are p hat equals 0 and 1. That's coming on the screen here now. And we're going to calculate the sample size n for various values of p hat. And you see them coming on the screen here now. This is a graph here. And for n equal to, for p hat equal 20%, n is 26.52. Now we're just substituting these in that formula. And watch what happens. We find that when p is equal to 50%, this gives a maximum value of n of 4144. Higher values, of course, the n values start to decrease, and the maximum value of n is 4144, occurs when p equal to a half, and we simply substitute that into this expression up here, and we find that the sample size n, without any knowledge of what p is given as a maximum value of 4144 actually. When p is unknown, we set p equal to a half, and this becomes our general formula for the sample size n. Well, that's the end of presentation 7.8. We ask you to review once again and go to 7.9.